talk today about how Ramp uses Materialize and DBT to fight fraud. We also want to do a deep dive on Materialize, how it works, and also how it integrates with DBT. And so I'm going to start off by talking about Ramp. Ramp is a finance automation platform. What that means is it provides finance teams with visibility, flexibility, and control about how companies are spending their money, while at the same time enhancing their ability, reducing undue friction and effort through automation and integration with accounting providers like NetSuite, et cetera. We have a few products like Ramp Cards, Ramp Bill Pay. We also just introduced a new vendor management solution. The product that's most relevant to this presentation, and frankly also the easiest for me to explain, is our card product. What it is, it's a corporate card expense management solution. If you've ever used American Express corporate cards, if you've ever used, let's say, Expensify or Concur, it's basically that, except better. What differentiates us is that we pair the card and the software into a single product, and that unification, that's what enables us to provide that enhanced visibility and control to finance teams. So Ramp's data platform team, which I lead, you can kind of think of us as like a hybrid DevOps and data engineering team. And so we're both building the infrastructure and tools to enable Ramp to realize value from data, but also we're spearheading the building of applications on top of that platform and partnering with stakeholder teams to do that. So in terms of stakeholder teams, Ramp has its own spin on EPD pods. It's basically EPD pods plus data, so it's better. And so these product engineering, design, and data pods, this is what will be formed at the start of it, let's say a new business objective to deliver on that objective. And so that means that data engineers, analytics engineers, and also data platform engineers are partnering with engineering teams at the start to build that analytical product that will maybe be embedded into the customer application. Maybe it's a data science model, or maybe it's just some internal measurement in our BI tool. So it leads to really great outcomes on our business objectives. So one such business objective is our fraud detection platform. And so this is something that we've been focused on over the last year, and it's something that we actually migrated to Materialize in the last few months. Fraud, it's a looming threat when you're running a corporate card business. No businesses can be spared from this, and a lot of different types of fraud. The two that I'd like to focus on in this presentation are account takeovers and transaction fraud. And so an account takeover, it's literally what it sounds like. It's when an attacker logs into an account with stolen credentials. Maybe they've phished it from an unsuspecting user in the past, and they're just now logging in. They log in, they create Ramp cards, they spend willy-nilly on jewelry, handbags, and power tools, actually. They go to Home Depot, they buy a $300 drill, they immediately sell that $300 drill on eBay, and they pocket the difference. Well, they pocket that $260. It's free money. So the other type of fraud is transaction fraud. Really similar to account takeovers in that the fraudster is spending money in an unauthorized fashion, but the difference is how that, let's see, the card is acquired. Maybe they just acquire the card number and the expiration date, et cetera, somehow, and they just start spending money. What's in common to both of these different types of fraud is two things. First of all, when fraud happens, it happens really quickly. And second of all, there is no upper bound in how many losses we can incur from some fraud events. So that means that speed is really, really key for that in order to minimize our losses from fraud. And so about a year ago, we built out our V0 system. It's based off of our batch analytical infrastructure, high level. So we can kind of frame the fraud features as, they're quantitative in nature, and you can derive them with SQL. And so it fits nicely with DBT. And so our initial setup is that we pull data from our application database, which we can derive all of our features from our application database. So that's our Postgres database that backs our front-end application. We have an hourly DBT DAG, Airflow DAG rather, that will run the ETL sync to load data from our Postgres database into Snowflake, run a small sliver of our DBT models related to risk, and then Bob's your uncle. Second of all, we have scheduled notebooks that are disparate from that Airflow DAG that will query those tables derived in Snowflake, determine if it's fraud or not, run some fancy Python function. It will trigger a Slack alert or otherwise alert some downstream system saying, hey, there's fraud, do something. And two disparate systems that are scheduled on an hourly basis. We hope that they schedule at the same time. They often don't, which is bad. And so what that means is that when a fraud event occurs, there's a gap between when it occurs and probably like an hour later when we actually realize it, which is okay, but it's not ideal. Speaking of things that are not ideal, let's kind of elaborate on that. So as I mentioned before, latency and freshness are hourly at best. As I mentioned before, speed is key. So data freshness is absolutely paramount for acting as quickly as possible and minimizing our fraud losses. So, I mean, a side effect, of course, we're running on Snowflake. Common story with Snowflake, oh my God, it got really expensive. This was no exception. Our costs quickly ballooned to about $120K per year annualized across Snowflake and different systems, which is no bueno for my finance team. So kind of piling on to the latency issue, this issue, actually both the cost issue and the latency issue compounds over time because the amount of data that we have to process grows with our business. Ramp is growing really, really quickly, which is great, but what's not great is that it results in longer DBT runtimes, which means more Snowflake spend and also a longer running DBT DAG. In fact, earlier when I said we run this DAG every hour, I actually kind of lied to you because we started by running this every half hour, but our DBT run got so long that we couldn't run it every half hour. At some point, it was actually, the entire DAG was running, let's say, once every hour and 15 minutes. Not good. So it was very clear that we needed to make a change. When fraud happens, it severely impacts customer experience. They feel like they've lost control of their money. Not to mention it impacts Ramp's bottom line. We, of course, eat those losses, not the customer. And as I said before, to stop fraud, speed is key. A batch analytical data warehouse like Snowflake is not sufficient for an operational workload like fraud. In terms of what an operational workload means, Nikhil's going to talk more about that and also talk about how Materialize works. Nikhil, please.
Thanks very much, Ryan. So there are broadly two different types of data workloads. On the one hand, you have analytical workloads, and on the other hand, you have operational workloads. We published a blog post a couple months ago that goes into this in detail. But briefly, analytical workloads are workloads where you're looking back at the weeks, months, years of your business's performance and coming up with what you're going to do in your business for the next weeks, months, years. And this is where batch data warehouses really shine. On the other end of the spectrum, you have operational workloads, where you need to respond to a new fact coming into your business in minutes or seconds. And what we find with operational workloads is almost universally, they are more valuable the fresher the data is. And you see this very directly in Ramp's use case. If they can shut down a credit card in 5 seconds instead of 5 minutes, that can save them tens of thousands of dollars in fraud because they can shut it down that much faster. Now, batch data warehouses are really good for analytical workloads because they grind over lots of data. And when you're looking back at weeks, months, or years, you need to be grinding over that data. But they start to fall over when you move in the operational direction. And maybe around a day they're all right. An hour you can make it work with some serious engineering. But as you need to get your freshness down to a minute or a second, they just can't keep up. They weren't built for that. They weren't built for freshness. And what you really need is an operational tool for your operational workload. But there's a lot to like about the batch data ecosystem. The data warehouse is really powerful because it's the first part of your pipeline where you can join together all of these siloed pieces of data from your business. Your marketing team has one system, your sales team lives in another system, and your engineering team is off building a bunch of applications custom for your business. But to understand your business, to have your reporting dashboards that tell you what's happening in your business, you need to get all of that data in the same place. And that is typically in your data warehouse. And because data warehouses have for a long time been primarily SQL, you can hire analysts. You can potentially even take people from your finance team and your operations team, teach them SQL, and they get access to all of the data in your business with a technology that's very friendly and easy to use, and their dashboards, their queries, their exploratory analysis, that all is powered by the data warehouse. You can even use a reverse ETL tool like a Census or a HighTouch to send the modeled data out of your data warehouse back to the SaaS applications where your marketing and sales teams live, for example, right back into Salesforce, if that's what you use, all thanks to the power of the data warehouse. Now, the problem with the data warehouse, as Ryan's been mentioning with the fraud detection use case at Ramp, is that the data moves slowly. It moves in big batches. If you're lucky, maybe you get it down to 30 minutes. That's where Ramp was able to get their batches down to. But often it's daily. You only have the last day's data in the data warehouse. If you want to know what happened in the last minute or the last hour, that's just not in the data warehouse. But we really liked everything else about this picture. And we didn't want to throw it all away. So we built Materialize, the world's first operational data warehouse. And it fits right into this pipeline that you already have. It connects to all the same upstream sources of data. You power all the same things off of Materialize. You still have your BI dashboards running off of Materialize. You can use reverse ETL tools like Census's new real-time sync to send the data back to these SaaS tools where your marketing, your sales, your finance teams live. But Materialize handles it all in real time. What used to be a slow 30-minute batch from here to here instantly flows into Materialize, where it gets computed with the same SQL queries that you're used to writing, that your team of analysts knows how to write, and then instantly flows back out to your downstream applications. So what does it actually look like under the hood? The core concept in Materialize, just like in your traditional data warehouse, is the view. You write your business logic, your interesting SQL queries, as views, and you give them names. And if you're using dbt, interesting query would be a dbt model that's installed by dbt run. Now, in a traditional batch system, every time you select out of that view, every time your analyst is exploring the data, every time your BI tool is visualizing that data, the data warehouse goes and grinds over all the data to come up with the answer. And that might take multiple minutes if you have tens or hundreds of gigabytes. And that data is already 30 minutes stale at best. Maybe it's actually hours or days stale. So your data warehouse has to do a lot of work to answer that question, and the answers it gives you are stale. The magic of Materialize lies in create index. All you have to do in Materialize to get fresh answers is create indexes on your interesting queries. That inside of Materialize spins up a data flow in our compute layer that does incremental computation. So even if interesting query is really, really expensive, even if it has lots of joins in it, lots of aggregations, filters, really nested, horrible, correlated subqueries, whatever, you throw that at Materialize. And computing it incrementally tends to be very efficient. When data comes in, you're not rewriting history every second. It's just a small amount of data every second. And Materialize only has to do a small amount of work every second to update the answers to all those queries. That means when you select star from interesting query and Materialize, the answers are already ready and waiting for you. We just hand them back to you. Materialize basically does no work to serve a query out of an index. And the data in that index is only a couple seconds out of date. Your freshness is down to seconds, not minutes, not hours. And one of the most powerful parts of Materialize is how well it pairs with dbt. One of the things that many of us love about dbt is how declarative it is. But dbt has this one imperative moment with batch data warehouses, which is you have to tell it to update the data. Of course, when you're developing, you do dbt run to update your models. That's fundamental. As you're changing the definition of the SQL queries, you have to propagate that change into your warehouse. But as your data scales, all the problems Ryan was mentioning about the volume of data compounding over time, your dbt run gets slower and slower. And you need to run dbt run when you want to update the results of your models. If you're using the table materialization or the incremental materialization, those don't update until you run dbt run. So you've got to figure out how often are you going to run dbt. Maybe you run it every day, maybe every hour, maybe every 30 minutes, but eventually you run into the problem that Ryan and his team ran into at Ramp, where it just takes 30 minutes to run dbt. You can't go any faster at that point. And you can get fancy with incremental models, but it's a lot of work to figure out, all right, this timestamp column here, it only updates like this, so dbt only needs to rerun this part. But you can't always do that, and you get away from the magic of SQL where you just write the business logic for the transformation that you want, and you have to do real engineering to make your incremental models fast. None of that's the case with Materialize. You just run dbt run when your models change. And Materialize continuously computes the answers to all of those models. You can run dbt just during the day while your developers are merging things to production. And while you sleep at night, all of those models are instantaneously updated. It even extends to testing. In a normal data warehouse, when you run dbt test, that's the moment that you see you have a data quality issue. In Materialize, you can install your tests as continuous queries, wire them up to Slack, immediately get alerted as soon as a piece of data hits Materialize that violates one of your many dbt tests. Now, you don't just have to take my word for it. Ryan is going to talk us through what using Materialize with dbt was like at Ramp.
Thanks, Nikhil. So we refactored our fraud detection system to be based on Materialize rather than Snowflake or analytic data warehouse. In terms of what that looks like, so we have Materialize at the center of it, just like the previous diagram. In terms of the pipeline, We have a CDC streaming pipeline that pipes the write-ahead log from Postgres and the Kafka. We use Debezium for that. And then Materialize natively integrates with Kafka. And so what the result is that we have sources within Materialize that are almost exact replicas of the upstream tables within Postgres. And so we can define downstream cascading views and index views based on that to enable the fraud alerts. The result is that end-to-end latency for the feature computation is it's about 1 to 3 seconds now instead of every hour, which is sick. So one part of the stack here that's still a work in progress is our policy layer or decision engine. That's still in scheduled notebooks, and so we were able to increase the frequency of that from hourly to every few minutes, which is huge for us. And so now we can actually lock the card or lock the account right as they're testing out that cordless drill in Home Depot rather than after the checkout. So yeah. In terms of managing Materialize with DBT, so we manage it similarly to how we manage our Snowflake-based DBT code. So Snowflake-based DBT, we have a DBT monorepo, a CI/CD process that will apply these changes into our data warehouse upon merge to master, and we have a daily Airflow DAG that will, as Nikhil said, run the DBT models with DBT run and DBT tests. So with Materialize, however, as Nikhil also mentioned, we only need to run DBT run when we modify the DBT model, and DBT will install these changes in the Materialize cluster, and then Materialize takes care of the rest. It will automatically stream the changes into downstream models, etc. And so because it warrants a different process, we actually have a separate repo and a separate CI/CD process for that. Yeah, I mean, in terms of another side effect that's really positive is it democratizes the definition of streaming pipelines, even streaming aggregation pipelines, which are notoriously difficult to non-data engineers. I now don't need to hire a specialized data engineer that knows Apache Flink to define the streaming pipeline. I can instead invite analytics engineers and even my fraud analysts who know SQL in terms of developing those streaming pipelines. In terms of our business outcomes, we actually had a recent ATO event in August, and we fared pretty well. 50% of hacked accounts were flagged as fraud before fraudsters could spend any money, something we couldn't do before. In terms of how this event fared versus previous events, I mean, it's kind of dubious to compare events, but I'm going to do it anyway. We had compared to, let's say, an ATO event that happened last year, we had about a 60% reduction in total monetary loss rate compared to that event. So that's a lot of money. So definitely justified our spend on Materialize and also our engineering effort there. In terms of our future plans, I mentioned our decision engine. It's still notebook-based. We're a startup, so this is what we did. Don't judge me. In terms of what we plan to do next, we want to build some more event-driven decision engine, maybe something Kafka-based. I'm not entirely sure, but it's probably going to be some sort of pub sub-model where we publish these features to this consumer, and the consumer does the things, evaluates whether it's fraud or not, and then alerts the downstream systems, and there we go. So that's it. Thank you so much for coming.
Thank you all. Appreciate it.
Any questions? Wait, do we take questions now or?
I don't know how the questions work.
Does anyone have any questions? Go ahead.
So don't want to be a party people, but snowpipes and dynamic tables, right?
Yeah.
Is it solving the exact same problem Materialize is solving? Or how should I think about that?
Materialize is faster than dynamic tables is how I would think about it. If you really need seconds or minutes of freshness, Materialize is also consistent. Dynamic tables are eventually consistent. So those are the two big things.
Can you expand on that a little bit more?
Yeah, so there's no guarantee that when you query multiple dynamic tables, you're going to see a consistent snapshot across all of them. So you might have fresher data in one that was simpler, and then you have a complicated stack of dynamic tables somewhere else, and that one is always lagging behind. And one of the things we really pride ourselves on at Materialize is getting correctness right in a way that a lot of streaming systems don't. So you can configure Materialize so that you always see a consistent snapshot across all of your views. So you know that if you're running two queries on two totally different stacks of views, you're always getting a consistent snapshot.
Thank you.
Yeah. Thanks for the question.
In the back.
Yeah. So it looks like it's really just kind of a view and an index. And
That's right.
it kind of looks like, at least in most implementations, you have Materialize sitting in between your operational layer and your data warehouse layer. Do you have any customers or use cases where you could potentially have it, let's say, reversed, where we have a data warehouse, we've done a lot of transformations with DBT, it's gone through all of our stuff, and then we want to use Materialize to get data back out to the business, where you reverse the data warehouse and Materialize on this graph?
So if you were to reverse these two, you lose out on a lot of the benefits of Materialize because the data in your data warehouse is probably stale, or at least stale enough that you're not going to get lots of value out of Materialize. So what we push people to do, the reason that we have it laid out like this on the diagram, is you lift those important transformations out of your traditional data warehouse and you put them in Materialize, and then you export them out of Materialize into your data warehouse. And that way you only have to do those transformations once, but Materialize gets to do them in real time, and then the historical values of all of those transformations gets offloaded to your data warehouse for later historical analysis.
Materialize also then, I guess it's a set of tables and what, is there like an API layer on top of it, or?
It's just SQL. So we actually have a number of users who build applications directly on top of Materialize. We even have an HTTP bridge for Materialize. So if that's what your applications speak, you can just run your SQL queries over HTTP. And Materialize can get very close to your front end. You need a little authentication layer on top of Materialize to make sure that users are only seeing the data that they're meant to be seeing. But you can build real-time data applications right on top of Materialize with very little code of your own in the way.
So there is an authorization layer that kind of comes with Materialize then?
Yes, but not one that you would want. You need your own user authentication layer for your users, and then you need a little service in the middle that makes sure that they're only accessing the parts of the tables that they're allowed to see. Yeah. You bet. Thanks for the question.
Any other questions?
Yeah, sorry. If you look at Materialize, so I see a lot of benefits, but you still think that data warehouse is needed here. If that's true, like what are the downsides to Materialize and why you still want a data warehouse?
Do you want to talk a little bit about why you guys still have Snowflake?
Yeah. I guess what I would say, Materialize is a storage engine for index view. Correct me if I'm wrong. It's an in-memory row store. Memory is expensive. So if you have a lot of data that you want to crunch through and maybe serve to your customers, and maybe latency, let's say 10 or 5 seconds latency is not really a huge deal. Snowflake is a much more cost-effective way to do that. So anything to add?
Yeah, no, that's exactly right. Every month that goes by, Materialize gets a little bit better at using memory efficiently, paging memory out to disk. And over time, there will be less and less that you need a traditional data warehouse for. But if you're going to grind over terabytes of data, you need something like Snowflake, BigQuery, Redshift. That's always going to be the case, but 100 gigabytes of data, that's something that we are pretty good at today, and we're going to continue to push the envelope there and increasingly handle larger and larger data sets cost effectively.
The only thing I would add is, I mean, if you're, let's say, running large historical analyses, like I want to know what these features were on yesterday and today or the day before that, et cetera, that's where, let's say, some offline analytical data warehouse would be better. But if you're just calculating this feature for today, you just, the current value of it Materialize would probably be a better solution. Yeah, please.
Yeah. So you mentioned you're spending like $120K a year on Snowflake. So has adding Materialize helped cut that spend, or basically are you net even at the end of the day?
It's probably about 10x cheaper on Materialize, and we get probably about 1,000 times better freshness.
Okay, so you cut all that spend, or just part of it?
Most of it.
Oh wow.
Most of it, yeah. So, yeah, it's pretty slick. Definitely. Cool. Please.
What are the native integrations of Materialize? Like what can it read from, and what can it do without? So
Kafka and Postgres for sources and Kafka for syncs. And we have a webhook source that launched in public preview, I think 2 weeks ago. So that's a very easy way of plugging Materialize into basically any system that supports webhooks. We have more on the way.
but if it's like a high volume output, like going back to Snowflake, it will be writing Kafka
That's right.
and then doing Snowpipe or
Right, and the reason we push it to Kafka is because that lets you dial around yourself how frequently you want those updates in Snowflake. We have a batch data export to Snowflake if you don't care about staleness, which is often a lot of use cases for Snowflake, coming this quarter. Yeah. Yeah, so that'll be a more direct way to get data out of Materialize into Snowflake.
Other question. I think there was one in the back somewhere over there. Hi, yeah, please.
I was just going to ask about the ingest story, which I think we touched on.
What? Is that your story or mine?
Well, just what does it look like? It's Kafka and Postgres to get data into?
Those are our two native integrations right now. We also have a number of folks who are using the new webhook sources because if you've got any data anywhere, it's very easy to rig up a little service to send that to Materialize over a webhook. We're also looking at integrations with a couple CDC partners. Fivetran, Stream, everyone is increasingly interested in real-time CDC, and we are here for it. So as soon as those CDC providers are able to get away from a batch size of 30 minutes or 5 minutes and down to minutes or seconds, we are ready for it. So we'll be able to plug and play just as soon as there is a CDC provider on the market that can deliver real-time CDC. Yeah.
So building on that, is it your prediction, put on the spot, that ultimately in the future everything moves to real time? If we're talking 5 years here, that everything is now real time, and that if we look back now, it was a moment in time that analytical and operational were these two separate things, but ultimately it sort of all moves to real time operational.
That is certainly my great dream, that real time will become easy enough that you can use it everywhere and cost effective enough that you can use it everywhere. I think the cost efficiency is always going to be a little bit hard, but we're thinking about how do you auto scale resources and Materialize so that you just auto scale things on and off in response to load, recover a little bit of your costs. And from that, Materialize looks a lot like Snowflake if you turn it on once a day and then turn it back off. So that's an area we're exploring where you can lean into it. And I think you're always going to have this framing of analytical and operational workloads, but there's no reason in the limit you're going to need two separate tools. So that's the grand vision for Materialize. When you want real time, you need Materialize. You just have no choice but to lean into an operational tool. And we can slowly grow into the analytical use cases over time. Yeah.
Other questions?
For your data science model, so is it at some point do you guys see that running on Materialize, being able to run some
Data science model,
fraud detection?
So I mean, in terms of running the model, like the XGBoost or whatever model itself, I'm not sure about Materialize's roadmap, but in terms of deriving the features for that online model, yeah, I mean, Materialize would be a great solution for that. So, yeah. So we could theoretically take these fraud features and replace this rules-based policy layer with some model-based approach, yeah, definitely. Other questions? Going once, going twice. Okay, Soul. Oh, nope, go ahead, sorry.
Is there any sort of agenting from Materialize that help? And sorry if I missed that. A stream?
In Ramp's case specifically or in general? So in general, yes, there are two ways. We have streaming SQL. You can subscribe to the results of a SQL query. We didn't show it here. It's one of the coolest features in any database, although I'm biased. And there's also a Kafka sync. So if Kafka is how you prefer to receive your streams, we have a native Kafka sync in Materialize. Yeah. Yes, we have a booth if anyone has more questions. We would love to talk your ear off about Materialize, especially me. So if this is interesting to you, if you think there are use cases for Materialize at your business, come stop by the booth. We are right in the center of the activation hall.
Cool. And I think with that, we can wrap up. Thank you all so much.
Thank you all for coming. This has been fun.
That went well.